Now, section 4 is going to combine algebra and this idea of transformations. And what happens when we look at algebra and transformations is we start talking about something like parent functions. Now, these are our original base graphs or equations, and then we're going to start transforming them. We're going to stretch them, we're going to shrink them, we're going to shift them left, right, shift them up, down. And there's rules for all of this. Now, you've done a little bit with parabolas in Algebra 1, and we're just going to build on this idea. So our parent functions we're going to call our base or our original functions. Remember, function is a fancy word for equation. So a couple of key terms. Remember, the X intercept is where a graph crosses the horizontal axis. Okay, so when you have a graph, that X intercept is somewhere along here. And we find that what the X value is when we let Y equal 0. Another important line or point is the y-intercept. That is, again, where a graph crosses the y-axis. We find that when we let the x-coordinate equal 0. These are key points in a lot of graphs and things that can help you look at the function, check its behavior, and be able to graph it quickly and easily. Now, I've already talked about what parent functions are as our base or original functions. Now, the quadratic. This is our parent. Our basic f of x, remember f of x is a fancy way for saying y, equals x squared. This makes our open up parabola that we are all very familiar with. So if you think about making a t-chart of this parent function, if you put 0 in, you get 0 out. If you put 1 in, 1 squared, you get 1 out. If you put -1 in, you get 1 out. If you put 2 in, you get 4, -2, you get 4. And this is that parent graph that you get. So some key features. We can look at the quadratic in standard form, where we have ax squared plus bx plus c. We can also look at it in vertex form. Here's your a, which is the same. Now I have x minus h, the quantity squared, plus k. And these k's and c's look alike, but they are different. So how can we go about finding and handling these different forms and equations? So to find the x-intercept, you let y equal 0 and solve. Now this may involve factoring or using the quadratic formula to find those points. And remember, there can be 0, 1, or 2 x-intercepts with a quadratic. Now the y-intercept in standard form is c, so that's really nice. Or you let x equal 0 and solve for y. And there will only be one y-intercept in a quadratic. So one of the key reference points in a quadratic is to find that line of symmetry. So in standard form, the line of symmetry is a great reference point. And remember, we find that by taking the opposite of b over 2a. The reason this is so important is that gives you the x-coordinate of the vertice, of the vertex. You substitute that into the equation, solve for y, and you have your vertex. Then it's very easy to graph from there. If you're in vertex form, Your vertex, that bottom point of your parabola where you turn, is at HK. So this H and this K. And notice that minus sign. So what transformations happen? So A tells you a couple of things. Positive A tells you it opens up. A negative A, it opens down. That's the first thing that A tells you. It also tells you about growth. If your A is a fraction, okay, it slows your growth. It makes it flatter. If your A is some number bigger than 1, it grows faster, or it's really steep. So a slow growth might open up like this compared to the parent, which opens like this. Something that's multiplied by 3 might get very steep and open up very quickly, like that. So you know all of that from A. Now H is going to be your right and left movement. And so if you have x minus h in that vertex form, that means you go right h units. If you have x plus h, you go left h units. So you can take that vertex and move it left or right h units. Now again, these are in vertex form. K is going to be your up and down. So if you have plus k, you go up k units. If you have minus k, you go down k units. And so that is how you manipulate that basic f of x equals x squared into something different by shifting it left, right, up, down, and changing its rate of growth. T-charts, where you find the values, always work, but here are some additional tricks that can help you maybe graph a little quicker. So go ahead and tune in to the next video.